Bismillahirrahmanirrahim. Assalamu alaikum. My name is Muhammad Asim. I'm working as DevOps engineer. Guys, in this video, I'm going to show you how we can set up end-to-end encryption in our microservices architecture. So what we are going to do, we are going to use the EKS cluster. So what I've done, I've already spin up the EKS cluster. And if you see in my past videos, I've already made videos with regard to the EKS blueprints. So definitely, I've deployed Terraform and I will provide you the code. So in order to deploy this EKS cluster, what you need to do, simply clone this repo and you need to navigate to this branch end-to-end encryption. Previously, I've used the branch master. And for that branch master, I've used this video. I mean, in the previous video is going to be with regard to the monitoring, how we can monitor error, latency, network, and monitoring with Istio. But the coolest thing regarding this video, I would like to share that we are not going to actually um, configure, or I should say, the zero configuration of Istio will provide us the almost end-to-end encryption in our microservices architecture. For instance, you are a company with the requirement of HIPAA compliant, or you're a financial sector where you want end-to-end encryption and you want a mutual TLS in your architecture, how we can achieve that by using our existing infrastructure. For instance, we have deployed the infrastructure by using the load balancer controller. We want to use application load balancer controller for our services, and we don't want to use Istio as a like rules for our routing of traffic. So how we can achieve that? Because we have already covered for just I'm assuming that we have covered we have set up all the rules on our ALB ingress controller like that, and we don't want to use HTO. So this is the use case we want, but we want MTLS secure encryption and decryption of our services. So regarding this, what I've done, I've already cloned that particular repo. I told you you need to set up a custom VPC. You can do that, and let me show you some of the part regarding that particular site. So what I've done, I've created the backend, and you need to navigate to this VPC section, do Terraform init and Terraform apply, right? So it is going to create that particular backend. It is going to create the VPC for you, right? And it's actually at the backend calling this particular VPC module, right? So then what you need to do, navigate to the EK section and cd into that particular guy. And what it does, it is going to call the same bucket from the backend, and it is going to actually set up the EKS cluster for you. And this is the configuration, right? But if you see, it is calling that particular module, which is the manage module. We are using complete manage module here, and these are the modules we are using. So other than that, that is very important regarding the add on. We need to set up the load balancer controller, application load balancer controller, right? So in fact, the name, actual name is the load balancer controller, which creates the application load balancer and network load balancer. So what you need to do, navigate to this section, right? And you need to set up the backend, and then in the main TF, you need to also update the bucket as well, where you calling, because we are using the data, and it is going to pull the data from your S3 bucket, right, which is going to be the backend, and do all the stuff which I've defined here before moving on. So in EKS, I've used a different approach. It is going to pull the data not from the backend. Just to show you, it is going to pull the data from AWS, which we have already covered the VPC. So it is going to look for the tag and this name. So this is going to be the name of VPC, and I'm using the same name with the EKS cluster, right? So this is the little demonstration regarding the EKS cluster, what I have set up. Detailed videos I've already shown you. I've covered in my EKS blueprints where I use the EKS IAM, and all that stuff is going to be automatically through the Terraform. You don't need to do anything. You can watch the particular video. I can add that particular link as well. So in this demo, what we are actually discussing here, the end-to-end encryption. So in past, I covered this latency tracing, that stuff. So in this section, you need to navigate to the sidecar, and we are going to use the concept of sidecar, where which is actually the helper container, and we are going to set up the first of all, we are going to sign ourselves, sign certificate with this script which I've created, and we are going to sign for 100 years. So what I'm going to do, let me show you that part. And if you navigate to the section, I've already included that particular script, which is the bash script. So navigate to this section, and this is the bash script, guys. So I'm using this particular domain. If I navigate to the section, in the domain section, you see this is my hosted zone. I need to put that hosted zone in this particular domain section, and we are going to use this particular, I mean, uh, for every domain, right? So, and this is going to be for 100 years, right? And this strict wildcard mean you can use any subdomain, right? So anyway, we are going to use this particular script. I'm not going to go all the details regarding that particular script, but if you see my videos in past, I've already used this script, and detail I've already covered in my previous videos. So we are going to use this particular self-science script, and we are going to use this particular script, and we are going to actually use the Nginx, and that particular Nginx actually calling our backend application, which is going to be app. And but let me show you that. First of all, let's create that particular script, and on that particular. So what I need to do, let me take a shell into the container. So let me take a fresh shell, right? Previously it was already open, so I'm going to do the fresh vector shell into the sandbox, right? And let me do that. So I've already cloned this repo for you guys, and if I navigate to this Kubernetes Istio, by the way, regarding the Istio 1.117.2, I've already installed the Grafana, Kiali, and all this stuff. If you want to see, you can watch this particular video. I will add that particular link how you can set up easily. So definitely, I'm not going to cover in this video. And so what we need to do, navigate to the sidecar section, right? And as I already updated the domain name, so I'm using the same domain name which I've already shown you, or the hosted zone. So I'm going to simply run this particular script. What it does, it is going to create a directory with the name TLS, and in that particular directory, you'll see the cert with that particular domain name and the key as well, with signed with the CA. So let's do that. So it has already done that. So let me show you. So you see, it has created this directory TLS, and in that we have all the certificates. For instance, this is our domain. We need this key, and we need this cert. So this is our domain name, right? And this is the key we need, and it is actually signed by a certificate authority. So we have signed for the 100 years. What we are going to do, we are going to create, let me show you this part. If you navigate to the section Istio, right, and in the readme md, what I've done, I did the command. So what we are going to do, we are going to create a secret, right, from that particular file. From that particular file, this is the name of my domain. We are going to use this particular key, right? And we are going to use this search. So, and it is going to be in the default namespace. So what I'm going to do, copy this command and simply paste it here. So what it does, it is going to simply create one secret in my default namespace. So if I do kubectl get nodes, and if I do kubectl get secrets in default namespace, kubectl get secrets in my default namespace, you will see that one secret is going to be created, and I'm going to show you, and this particular secret is going to be in my lens as well. So what you need to do, navigate to the section config map, okay, secret in the default namespace. You see this has been created about 20 seconds ago. So if you click this guy, you can see all the cert and the key is already there, right? So guys, now what we are going to do, we are going to do other stuff. For instance, first of all, we are going to set up strict MTLS, right? So let me do that, and I'm going to simply tell you what this file means. So what it does, it is going to do strict MTLS with all namespaces. For instance, the difference between strict and permissive is that what permissive is going to do is going to allow HTTP as well, which means that it is not going to look for the certificate which are actually created by the sidecar proxy of Istio. Um, so Istio D has three elements: file, citadel, and gallery. Citadel is actually responsible for this cert uh, management, right? And it is going to do automatically for us. So in order to visualize what I'm going to do, I'm going to simply navigate to the section Istio system. So if you see the deployments, I've already deployed the Grafana Istio D. How you can do that easily, you need to navigate to my videos. So you have to watch this particular video. You can do it hardly in 5 minutes, right? So what I'm going to do, navigate to this section regarding the services, and I'm going to I'm going to do port forwarding. So I've already done that in past. Let me stop that particular section. And if I navigate to this port forwarding, so it has been stopped. I'm going to take another Kiali port forwarding, and you can do through the command line as well, but definitely I'm using Lens. So you can use the Lens. It is very convenient pathway to manage your clusters. So I've already made video with regard to that. You can watch that particular video, right? So if you navigate to the graph section, so currently we don't have anything, but the reason for navigating to this Kiali right now is if you click this section, you see mesh wide MTLS is enabled configured by default. So if I navigate to this section, sidecar and strict MTLS, and I've added the documentation, official documentation link as well. So if you navigate to this section, so peer authentication in a strict mode, I've already told you what it is. So for instance, if you deploy your application in other namespace, for instance, other namespace like foo, and I mean, it is going to be by default HTTPS. For instance, if you forget to inject sidecar injection in that particular namespace, you you can be prompted that it should be through the MTLS. So regarding that particular section, I've already added that particular part, and I'm going to show you some of the stuff which later on what we need. So, other than that, what you need to do to make sure what I've done, I've added the label, the namespace. For instance, we are going to use the default namespace for the deployment of our application. So I've already done this. Let me check that. And if I do namespace enable, right? So, okay, so default namespace not labeled, and okay, let me check from the you can check from the command line as well, if, but from the namespace section navigate to the default. So you see this injection is already enabled, so that's why it's giving us that prompt anyway. So if I navigate to the default section, currently we don't have anything in that particular section. So what we are going to do, if I do ls here, we are going to apply one sidecar ML. So this part I will cover later, but let me apply this section kubectl apply, and I'm going to show you this file, what we are actually doing here. So regarding this sample application, I've already covered in my previous video. If you want to see the detailed video regarding that, you can do. But we are going to see some of the stuff what we are actually doing here. And this is the sidecar Nginx with the configuration. We are actually calling our web application on localhost. By using the sidecar, you can actually call the other a container in the pod by using the localhost. And you can say the service discovery is going to be on localhost, just like your local machine. So this is the easy concept regarding that. So if I navigate to this section, for instance, if I click this guy, sidecar YAML, let me scroll up and start from the start, right? So regarding that, some of the stuff regarding the Nginx configuration proxy, I've already added the link, official AWS link. But this is the sample I've taken from the GitHub repo. I've added the link as well. In past, you can do this is the basic deployment services. One service is calling other services, and it is the Spring Boot application. So the different part regarding that particular section, I will show you just below here. So what I'm doing here, actually, I'm doing the config map regarding the Nginx configuration, and I want SSL configuration 443. So what I'm doing here, if you see etc Nginx SSL, this is the info regarding my cert. So if you navigate to the section um, config map secrets. So this is the TLS secret, right? We have created, and this is the info. You see, this is my domain dot cert, and this is my domain dot key. So if you check this, this is the domain dot cert, domain dot key I've defined here. Proxy, I've already told you the concept. My application is going to be available on local host, right? And rest of the setting, you can see these are the basic Nginx setting, and I've already added the link. You can watch that particular area. So the whole point here is actually complete end-to-end encryption, and this is the deployment Fleetman web app, right? And this is the web app we are going to use, and it is going to be on same pod, right? And this is the app and web app labels. It should be matched. So if I navigate to this section, you see I'm creating a service, and I'm going to calling this web app, and it is going to be in the default name section, in the default namespace. And if you see, it has the label, but if you see, it has the selector app web app. So if you navigate back to this section, you see, if you see match label app web app, it is going to call that. And the, the most important thing you need to see in this deployment, we have two images. So one image is going to be the actual application, right? And the other image is going to be the Nginx, excuse me, in the next part. So I'm using latest here. You can use Alpine or whatever, but this is the demo. So I'm using the other image as Nginx. So as I told you, in this particular pod, we are going to use two containers, and because this is the sidecar container, what it does, it is going to, and this particular pod, Nginx, has this configuration volume mounts as well. So etc Nginx conf.d, it is going to be a read only, and the SSL configuration, we are going to use this mount path and read only true, right? These are the volumes, right? And the secret name we've already created. This is the secret name. If you navigate up, so I've already defined the config map, and these are the locations where it is going to look for the certificates. If you exact into that particular pod or container of Nginx, you will see that particular area with the symlinks pointing to the actual location. So anyway, this is the configuration regarding to the Nginx. This is pretty much the basic regarding the sidecar, or you can say that two pods in the same container, and it is going to call, and the Nginx is going to call localhost, because this, if you see this particular web app, it is going to be available on port 80, and this web app is going to be listening on port 80, and we are actually in the, if you see here in the config map, right, this area, we are going to proxy to that particular web app, right? So that's it regarding that. So anyway, if you see, other services are actually listening on port 8080, but those services nothing to do with that. So we have done the configuration. Let's try to apply that. So, and the service, actually I'm calling this web app 443, and it is going to be the app web app. So the name of this is going to be this deployment. We are going to use the selector, this app web app, and the name of the service I've already intentionally put the same, and it is going to hook up with that particular deployment. That particular deployment has two containers in the single pod. So that is the architecture. And with the certification, with the certificates, I've already shown you that what we are going to do. So let's try to apply and see what's happened. And hopefully, It should be deployed in case of any error. We are going to look that. So what it does, okay, let me check that. So I guess I've already applied it. So navigate to the section in the pods. So yes, I've already applied about 6 minutes ago. So I forget it. So leave it. So if you see, one is going to be your application. This is the Istio proxy, right? Which is actually itself is a sidecar set up by the Istio D, and it has three component merged in that particular sidecar. And you see, this is the Nginx. This is the name of that particular container, and this is our web application. You see, this is the web app. What it Nginx do is actually looking for that stuff. So if I navigate, let me show you some of the stuff regarding the shell. So I'm going to take a shell into this guy and simply if I do etc ssl and do search, you see, okay, let me check the location. So etc nginx ssl, right? So if I navigate to etc nginx, let me do that. If we do ls here, you see our cert and key are available. So this is the thing I just need to show you regarding that. So what now we are going to do, we are going to apply the ingress.yaml. So let me close that part. So we are going to use the ALB ingress, but I mean, we want the application load balancer. Just normally in routine, we do our, setup regarding the ingress. So um for that, we need to have already available ALB ingress controller. So I've already covered. You can simply do that with the EKIS blueprints. In past videos, I've covered that. So now what we are going to do, um, because this particular load balancer controller is running, we are going to set up this. And what it does, it is going to be internet facing. Target type is going to be IP, which means it's going to directly contact our Nginx port directly, right? On that particular port, which is actually 443. And if you see the backend protocol is HTTPS. So, and the health check port is going to be HTTPS, and it is going to be 443 because we are using the self-signed certificate. But what I've done, if you navigate to this section, I'm using the AWS cert. So if I navigate to this is the cluster, let me close it. So let me let me navigate to this section. So what I've done, we will be using these certificate issued by AWS. If you navigate to this section, this is the ARM of that particular cert. And if you navigate to this section, this is the ARM you have defined, right? And it is going to redirect traffic from HTTP to HTTPS, right? And this is the extra layer, extra security. If you want to enable, you can use the Cloudflare, and it is you can use the Cloudflare side ranges to allow traffic from those, and it is going to automatically update the security group of the application load balancer to only allow traffic from the uh, Cloudflare IP ranges, which is going to be IP version 4 and IP version 6, right? Anyway, we are going to use this domain name, and it is going to, you see backend, it is going to call this web app on port number this. So let me apply that, what it does. Now I'm going to simply do kubectl apply and hyphen f to this ALB ingress YAML. So what it does, it is going to spin up an application load balancer, and it is going to create the target groups. But you will shortly see the health of the. So if I navigate to this section, and you will see the load balancer is going to be in provisioning state. Previously, I've tested that, so that's why you were seeing that particular guy. So it is in provisioning state, but if I navigate to this target group section, let me navigate to this section, target group. So previously, I've tested it. So this is the new target group. So we don't have any target group, but the initialization process of these 10 containers I should say the pods are going to be done in different availability zone, US1A, 1B, C, with highly available architecture. But the point I just want to make here, uh, it is those are going to be unhealthy, right? And let me show you. We need to wait for a while regarding the application load balancer to spin up. So let me refresh this part and wait for a while. So till then, what we are going to do, we are going to make one DNS entry, and that particular DNS entry is going to be exactly with the same name, web app. So simply navigate to this section. You need to type web app, and we are going to use the alias. So simply click this guy, and we are going to set up the application load balancer. You guys might wondering that why I am not using the CNAME. Although CNAME is possible, but AWS do recommend to use the alias record. What it does, it is going to do automatic failover automatically because the settings they have done. So they do recommend to set up the alias record instead of CNAME records. So that is theory little behind that. So application load balancer is now available here, and I'm going to just want to double check web app. Simply create this particular DNS record, right? And shortly you'll see all this stuff is become unhealthy, right? And if I do refresh it, application load balancer is actually sending HTTPS request on 443, but you're watching that. Let me do refresh here. You will see that you see this is now available, and but these are actually unhealthy. Why these are unhealthy? Let me tell you this particular part. From this uh, graph, you will understand what's happening. So what you need to do, navigate to this display section, click all the stuff. For instance, throughput, traffic distribution, traffic rate, and idle node edges. And one of the portion you will see regarding the security in the top bottom, this one, right? So click this guy. So this we have already seen. So if I scroll it down, so this is our application load balancer. It is saying unknown, but the thing is that it is sending request to this web application on 443. We have unhealthy target because we have added the policy that everything is going to be strict, right? But the reason for our pods are in unhealthy state is that if I navigate to this section, I've already added the useful links here. We need to allow the traffic port on 443 because we are using the self-signed certificate. What in theory, if you see this guy, the side proxy. So what Citadel does do, it has own management of certificates it generates, and it is going to do mutual TLS. You see, these are the padlocks. So they are using their own certificates to in order to communicate, and those are actually mutual mean do verification on both sides handshake regarding the certificate management, and it is done via this proxy which is running. This is the proxy I'm talking about, right? So Istio proxy. So this is how the mutual TLS work. Traffic is HTTP request sent to other pod, and which is actually going through that particular proxy. This is the proxy, and it is going to then route it to other pods, right? So, but what we have applied the strict policy now here, we are going to only allow 443 more disable, but we are actually knows that we have actually properly configured the certificates. For instance, if you check this area, the port is 443, backend protocol is 443. We are using our self-signed certificates, which are actually valid. So what we are going to do, we are going to apply this policy less by simply allowing this port 443. So let's try to apply this one. Um, Allow a specific namespace port permissive, right? So we are simply allowing this particular port, and the rest of the stuff, if I navigate to this section, is actually completely mesh wide MTLS is enabled. So shortly you will see this is not going to be instantaneous, like it is not going to be taken, for instance, is like your unhealthy pods are going to be healthy. You have to wait for a while, maybe half a minute or minute. So the policy is going to be implemented. So here, what we are going to do, we are simply allowing the traffic here on 443. You see, it has now traffic is now started to come. What happening here? Application load balancer is doing the health check on 443 port, which is of Nginx. It should be healthy. So, because we not open the app in the web browser, but we are able to see the traffic animation and the traffic routing already, you see. And from our web application, let me show you this part. So if we have different graphs here, so let me show you this part, right? And okay, see other graph. Okay, app graph, and we have um, this workload graph. Okay, and these are the graphs. So let me show you all the stuff. So if I navigate back to this section, okay, right? So this is our Nginx, this is the mutual TLS, and some of the stuff you want to see regarding the default workload. And if you need to simply click this guy, you will see workload here means that pod, and this app, graph, and failures, and everything is going to be explained here, right? So if I navigate back to the section to my target groups, you see now they are healthy, right? So we are actually allowing that particular traffic here, and we are saying that traffic, because application load balancer is going to automatically check the health of those particular pod. That's why it is going to say the targets are healthy, right? And let me now navigate to the application. I'm going to use the ALB ingress. So I'm going to simply copy this guy, and I'm going to copy this port. Copy this domain name, and I'm going to put that in a browser, and let's see about our application. So we are not using any, sorry, I should remove this. We are not using any Istio routing rules, or we are not using Istio gateway, and but we are pretty much still able to you see access our application, and you see that our application is running. So let me do refresh here. You will see some of the other stuff are going to be shortly populated here. And the beauty of this particular Kial is that you can see what is going on with your application, and you see that our application is running fine, and you can do other workload graph, version graph, and you can see this traffic split, and everything is going to be available. So that is the understanding, guys, regarding that particular end-to-end encryption. And if you see, we are sending request to our application here, and let me show you the stuff regarding the target groups. So if you check the health section, HTTPS, and the protocol is HTTP. So if you see my previous video, let me start from here. And the other part, I just want to show you, if you navigate to this target group, if you see, click this guy, and the traffic from the load balancer to your pod is actually, you see, on, if you check this health check, the protocol is HTTP. So this is the protocol previously we have HTTP. You see, all other stuff are actually being populated, and our application is running fine. We can see other stuff, regarding latency, but you see clearly our application is with emptyless. In the last, I'm going to add one more stuff regarding the Grafana graph. You can, by default, by applying that particular stuff, you need to watch particular video. So if I navigate to this Istio system, and I'm going to simply do the port forwarding to instead of pod, I'm going to do port forwarding to the um, service, and we are going to use the port 3000, right? And let me do that. And what I'm going to do, simply I'm going to import this particular JSON Istio Grafana dashboard. So by default, you will get the graphs. So what you need to do, if I navigate to, let me show you browse and click Istio D, you will get all these stuff with Istio D. For instance, okay, Istio service dashboard. So click that particular guy. You will see some of the, in fact, most of the stuff is going to be already populated. Let's say we want to import one of the stuff. So click this section and click import, and I'm going to paste this JSON here. I'm going to press load here. This is the HT Grafana, but I'm going to use this particular directory. I'm going to simply import that particular guy in this directory. So you see, we have the default namespace, and these are the, I mean, Kubernetes pod we have in our area, right? So we can check the latency, P99, and everything in the Grafana dashboard as well. So that is it, guys. If you like the video, like, share, and subscribe the channel, and have a nice day. Thank you very much.